In this video, I'm going to show you how I built my 24 volt lithium iron phosphate battery pack with a main on-off switch and a pre-charger to charge your capacitors in all of your equipment. So I have 230 amp hour cells. They have a compression on them with these threaded rods, and I've got a fuse, all of my balance cables, my BMS, and an Anderson connector on the end here. I will show you how I've done it in this video. Now, one of the first things I want to do is decide how the batteries are going to sit inside of this enclosure. So the way I'm going to achieve this is I'm going to be using threaded rod to sit on either side of the battery, top and bottom, and on the other side. Then I'm going to be using aluminum tubing and then drill a hole and have the rods come through and use this to compress. Now I could use a piece of wood up against here, I'm just going to use a cutting board I got from the dollar store, and I'm going to trim this down with my table saw so that it will fit up against here. Then I'm going to have my bar, and then I'll have my threaded rod coming through to compress the cells. So I've got to fabricate everything I need to accomplish this. Cutting board's cut, worked out perfectly. So now when I have my cell, I'll just have one of the boards up against it like that, and then the rods are going to go on either side to compress. So I do have some leftover ones from another battery build I did. All I'm going to do is I want these hole spacings in a little, so I'm going to turn this bar sideways and then have it sit up against like that. Now for my spacing for these, I'm going to take my 24 volt BMS and I'm going to have it sitting in the box down like this. I'm going to raise it up a little bit. So wherever the mounting holes are for this BMS is, I'm going to have my BMS mount the aluminum bar up against the cell during the compression. Okay, now I've got my 4 new holes drilled for my tension bars, I'm going to call them. So now I need to figure out where my BMS placement is going to be and screw that down. So it's going to be somewhere on here, like so. Now what I'm going to do is just measure out to the holes, make sure everything's square, and then I'm going to screw this down to here. I'm going to drill some holes on the outside here and drill these bars to this piece of cutting board, and that way it's going to hold everything together as I'm trying to align everything up. Now I need to make sure that when I drill this bar into the cutting board that I don't drill all the way through, because this is going to be pushed up against the cell and we don't want anything to puncture the cell. My plate's done. How this is going to work is this just going to sit on the end of the cell like this. Threaded rod's going to go through here on either side and keep these cells compressed or fixtured, and as well it's going to keep it from moving around inside of the battery box. I'm just securing down the BMS with some self-tapping screws into the aluminum. Now the BMS is going to be mounted just like that, away from the cells, as well as I'm going to have room at the bottom. Balance cables, I'm not going to be able to disconnect it from after this is all built, but that's okay. And I'm going to put on 2 new lugs here to the BMS running to where I need them to be. Now before I put my cells together, what I'm going to need to do is mark out inside the battery box where I'm going to be drilling holes through, because I'm going to have the threaded rods come out. I'm going to bolt on either side so that it contains the battery pack in here. So I don't want to have the cells just resting on the bottom here. I'm going to want to have some kind of cushion. So all I had done was I just cut out some flooring. This is just, as you can tell by this end here, it's just the flooring that goes together. And then I'm going to rest this up here Just doing a dry run of how I'm going to have the batteries in. So I am going to have to dip it in this side and then back it up into this side. But kind of right now, this is what it's going to look like. And my cells are all going to sit inside, which I think is going to work out just perfect. Then I'm going to have a on-off switch, which is going to sit right about here. But it's going to be protruding out, so there'll be enough room. And then, which is why I cut a piece of thin board, is I'm going to have that sit. I'm going to zip tie it onto the threaded rod. That way when the cells are next to it, if anything was to happen, if I was to get a bump on this side, it would bump into this board instead of bumping into the cells and possibly puncturing it. And I've already cut this down to give maximal room. So yeah, it's coming along pretty good. All right, back for another day of battery building. So I'm gonna have all my batteries lined up. What I'm gonna do in between each cell is I have some neoprene here. Just got a sticky on one side and then padding on the other. So I'm gonna cut these into probably 2-inch strips and run them along the cells in this direction, one at the top, one in the center, and one closer to the bottom. And then that way it's going to give the cells some separation and also allow for some thermal venting through the cells. So I'm going to cut this up into some strips and then I'll be back to put them on the cells. Okay, I have all of my neoprene strips cut. So now what I'm going to want to do is put them onto the battery. So I'm going to start with my outside cell. Now I'm going to have them roughly 1, 2, and then 3. I'm going to go down probably just about 1/4 inch from the top, about 1/4 inch from the bottom. Now I'm just going to put these on one side. This is going to be the outside. Next cell in between, I'll just put one strip down each. I'm going to get that done and I'll be right back. Well, I think that turned out rather nice. As you can see, not sure if you can see on the camera, but I've got all the strips in. So what this is going to do as well is not only is it going to help with heat distribution through the channels I've left, but it's also going to help to keep these batteries together. It gives a little bit more of friction between cells. And then the end piece is going to go on, and that's going to get compressed. Got a bit more fabricating to do. Okay, I think now I can put the threaded rods on. First thing I'm going to want to do is just make sure all the cells are straight. So the threaded rod is going to be sitting next to the cells, and these are rather sharp. If anything were to happen, these cells were to shift and start rubbing against here, it could cause damage into the shrink wrap. So what I've done is I just have some 3/8 inch tubing, and I've put it onto the threaded rod. So that way when it's next to the cell, there's no chance of anything rubbing into the cell itself. All I had to do was just put this over top of the bar, and then I'm going to come back, get my center point, measure out the distance that I need until my plate, and then I'm just going to take an X-Acto knife and cut this last part off. What I've done is I've covered the entire rod with the 3/8 tubing. So all I'm doing to cut it is I'm just going around once, down to the middle, and then just lay it down. And then take it off. Now I'm going to save these cut off pieces because when I have my tension rod sitting here and then this comes through, what I might do is this last bit between the outside compression piece and my box, I might put this around to protect any wires or anything. If I want to zip tie a wire around, then I can have this on here first and then zip tie the wire to where this tubing is. That worked out rather nicely. I have all my rods. Now it's going to be time to put the rods through with my end pieces. So this one here is going to hold the BMS. I'm going to want that on this end. Now I've got my carriage made, I'll call it. Slide it over the batteries. And there we have it. This is how it's going to sit inside of the toolbox. So now I can put my washers on. And then a split washer or lock washer. And some bolts. All the cells now are in the cradle. Before I tighten this down, I'm going to add my puncture resistor, fancy name. I'm going to zip tie that onto here before I tighten it up. This is roughly in the area where my disconnect is going to be. Next, I'm ready to compress the cells. So we'll talk about that for a minute. So I'm going to want to compress these cells. In the data sheets, I know specifically on the 280 amp cells. On the 230 amp cells, it just talks about fixturing them. It works out if you do the conversion to about 12 inch-pounds of force for fixturing the cells. Now that's not very much at all. So that's kind of why I put the neoprene as well, so it kind of holds the cells in there. Now if you look at the data sheet, but I believe without fixture, it's 1500 cycle life. And then when you fixture, I think it's 3000 cycle lives. So that's discharge and charging. So you're going to want to fixture your cells to increase the overall lifespan of your batteries. Look at your copy. I'll try and bring it up on the screen, but look at your copy for your specifics for your cells and whether you want to take the initiative to fixture them or compress them, as some say. But I'm definitely going to be compressing mine. All I'm going to do, because I don't have a torque wrench that goes down to 12 inch-pounds, which is 1 foot-pound of torque, all I'm going to do is tighten up these nuts until my split washer flattens out. And then that's how I'm going to figure out what my compression is going to be. So now it's going to be time to remount the BMS. To replace my wires, these actually came with 6 gauge wires. I'm going to upgrade these to 4 gauge. I've already gone ahead and replaced them once before to 2 gauge, but I'm going to downsize to 4. I basically had to take the bottom plate off the BMS. These lugs were screwed at the top end going down this way. So I had to go in and remove a lot of the BMS, take that out, and then I switched the holes, or switched the terminal lugs to the top side. All I did before was I just took a regular terminal lug and cut it down and then drilled 2 holes, and that's what I used to reinstall onto the BMS. Now I've cut these 2 lugs down. So what I'm going to do is this is the original. My lugs came out perfect. If you do go to do this, just make sure that you sand off the bottom here. You want this as flat as possible so it makes really good contact against the BMS. Now what I'm going to be using for my battery cable is a store here in Canada. I'm not sure if it's in the US, called Princess Auto. I believe they are in the US as well. Or like a Harbor Freight store. They were moving one of their locations and a bunch of their stuff, they were just like 80% off. We don't want to bother moving it. So I ended up picking this up for 80% off. This is welding cable and this is going to be 4 gauge. So now I just need to determine the length of run. I know that my BMS is going to be sitting here, and this wire here is going to come up from here, come down. I'll have it turn. Okay, now it's time to run my P negative wire. So my P negative wire is going to come out of here. It's going to come across and then it's going to loop out, and the Anderson connector is going to be roughly here. And reinstall the VMS into its final resting place. I think that came out rather nice. This is going to be my P negative. And then this is going to go into my Anderson connector for my battery connection. So just to kind of show you what I'm doing here with my balance cables is I've got a fan set up because I'm soldering, so I don't want the solder blowing in my face. But I'm figuring out where I have to run my balance lead. See if you can see that in the camera. Bring this up a little. So all I'm doing is I'm seeing where I got to run my balance lead. I'm going to run them around here. This has to go to here. So I'm going to cut off the old terminal connector. And then I have some short wire. I'm just going to run that into there. I'm going to cut that one. Strip. Get out of there. Strip it. Now I'm just splicing them together like so. Give it a bit of a twist. Take my soldering iron. That's good. A little bit of heat shrink. And there I've got an extended balance cable. So now I can run this over to my next terminal. Now I'm going to go through and do the rest of them. I finished installing all of my balance cables. I just tidied them up with some zip ties. and then I zip tie it around the threaded rod and then a zip tie through that so it's not directly touching the threaded rod. So now I'm gonna run the temperature sensor and the Bluetooth device. I seem to be missing the temperature sensor. There it is. Okay, so I'm gonna install the Bluetooth first. Now I'm just gonna run the Bluetooth module over here and zip tie it. I want to be able to get to this because sometimes you have to unplug this device, or there's a little on-off button here you have to get to. So I want it relatively accessible. And next is going to be the temperature sensor. Now, this is a very short temperature sensor. I might look into replacing it so I can put it more in the middle. Actually, temperature sensor, I'll have it come down and I can tape it right on here, right on the cell. I wish this unit had more sensors because then I can put some in different locations on the pack, but this should be good enough. So I'm going to use some Tapcon tape for this. Very, very strong tape. Okay, there's my temperature sensor. I think I'm going to hook it up now. I've got my balance leads ready, Bluetooth's in, temperature sensor's on. So let's build a battery pack. Main negative, so positive to negative. Be very careful because this is uninsulated. My main negative. 27.4 volts. So on the app here, 28.4, no amps running through. Let's hook the bench power supply up to it. See if I can't get a current going. You can see on the app I've got 9 amps going in right now to the battery. Slowly dropping a little bit. Get that back up. So there you go. Right now we have a working battery. So now what I'm going to want to do is I'm going to want to go take my dog for a walk. She's been patiently waiting for me. Come on. Alright, I'm almost at the finish line. Last thing to do is to work on the box to put in my main disconnect switch. I'm also going to have a pre-charger button so that when I connect my load before I turn it on, I can pre-charge the capacitors and whatever it is I'm going to be connecting. And then an Anderson connector to sit on the end so I can plug in all my devices over here and I don't have to open the lid. I could have also used battery lug terminals and just put them wherever on the box, but I kind of like the idea of having an Anderson connector, so I'm going to go with that. So all that's left to do is to measure out, figure out where my switches and everything are going to go, and then I'm going to slide the batteries in, hook everything up, and we'll see if it works. Okay, just to give you an idea of how that turned out. It's not the most prettiest, but I can clean it up later. So there's my Anderson connector. My 2 threaded rods are going to come through here. And this is how it's going to connect. So when I have my battery, connect it, and there you go. I have all my wiring complete. And just to show you, so it comes off of here, the positive, which is connected to the battery positive, runs through a 5 amp fuse, and then runs in and then it comes out on the two other sides. One goes to the pre-charger and the other one powers the light in here. And then I have my negative that I'll have to connect once the battery's in. I think I'm ready to put my battery in. So what I'm going to need to do is levitate the battery up here, make my connection for the other side of the Anderson connector. Then I'm going to have to put the 4 threaded rods in on this side, shift it over as much as I can when it's in the holes, push it up this way to come around past my switch, and then straighten it out and then go into the 4 holes over here. In theory, it should work. Wish me luck. Okay. Oh, I hope this goes in okay. Don't move. Now the grunting and groaning part. Yes! Okay. I've got one side in. One. All right, it's in. It worked. All right, I'm just gonna adjust everything. I've got these bolts here that are gonna come out, push against here, and then I've got bolts on the outside, and then I'll trim off any excess threaded rod. But everything's all tightened up and complete on the battery. I've got my main on off, got my pre-charger, and got all the bolts cleaned up on the outside. Anderson connector. I still need to figure out what I'm going to do to clean this up. I was thinking trying to maybe get a 3D printed cover for this, and then that way I can try and maintain a water resistance. You can see from the inside, everything's all tightened up. This battery is not going to go anywhere. It's nice, safe, and secure. So I'll show you that it works. I've got my Growatt 24 volt inverter set up. Plug that in. What I'm going to do is hold this button for about 10 seconds. Let the capacitors pre-charge off the 10 watt resistors in here. Now I'm safe to turn it on. And there we go, we have power. So right now I have a 24 volt battery box, toolbox, ready to use. If you've watched the video to the end, thank you very much. I know this one was longer than my normal videos. If you like this build, let me know in the comment section below. If you have any questions about this build, let me know. If you like it, like it. If you want to share it, share it. I'd appreciate it. And we'll make some more videos in the future. Thanks.